Welcome everyone. Thanks for attending this. My name's George Dolezal and I'm the Principal Engineer for Meyer Timber. Meyer Timber is one of the largest importers and wholesales of structural timber in Australia and a family-owned company that's been going since 1974. And as you saw in the introduction, I've been involved in engineering in the timber industry for 22 years now. But as you can also see from the other presenters, I'm still the least experienced in the group. So we've got a nice range of people here and a lot of experience to deal with. So just to start with, just have a look at what, because we've broken the presentation up a bit. So the new AS 1684 is really a minor revision until a major rewrite can be done. So I'll be looking at, first off, the layout changes, Section 5, flooring and decking, and then some information on pitched roofs descriptions between coupled and non-coupled roofs. After that, Tim will look at bracing and tie downs mainly, and then Boris will finish up with systems approaches and what is forecast in the future for the standards. I suppose to start off with, what standards does this apply to? AS 1684 has typically been broken up into 4 parts, and this 2021 revision refers to AS 1684 Part 2, which is the non-cyclonic areas, and AS 1684 Part 3, which is the cyclonic areas. Looking at the other 2 standards in the group, AS 1684 Part 1, 1999, was used and is still used as a basis for the span tables in the supplements. So it's still current and available. But most of you will know that this has been superseded in 2016 with AS 1720 Part 3. Then AS 1684 Part 4, which is the simplified non-cyclonic version, is still current and is based on the existing or the original AS 1684 Part 2 2010. Now, being a simplified version, it is not extensively used, but is still current at the moment. And finally, we look at the supplements or the span tables to both AS 1684 Part 2 and Part 3. They remain unchanged at present. What has changed? If you look at a standard, before the standard even starts, before the table of contents, there's a preface in there. And that preface normally outlines what the major changes have been in the last revision of the standards. You can see below there's a picture of the preface from AS 1684 Part 2. Now, if you really want to know what this is before you buy a standard or before you choose to, you want to see what has changed, you can actually go onto any of the online outlets, and I'll note these at the end of my presentation. And if you access that standard, there's a preview page there. The preview page will usually give you the first 5 or 6 pages of the standard, normally till after the table of contents and then the first page after that. And so it will actually, you'll be able to have a look at the preface and see what's been changed and what the major revisions are in the current version. So AS 1684 Part 2 and Part 3, what changes have been made? First, there are administrative changes. So there's been some changes in the order of sections to match the protocols for current standards. An example of this is the terms and definitions in the 2010 version were in Section 2. They took up a large part of Section 2, whereas now they've been brought back to Section 1 to bring it in line with the current protocols on how standards are laid out at the moment. There's also been a number of changes to comply with accessibility requirements for online documents. This is a protocol that Standards Australia have chosen to go with to allow accessibility for those who require it. And when you look at online documents and you look at things like the reading views and the automatic reading of online documents, there's certain protocols that need to be taken to allow this to occur effectively. The main areas you'll see the changes are in the tables, particularly in sections 8 and 9. Section 8, which is the bracing section, and section 9, which is the tie-down section. There are a lot of tables there which were combined. As an example, down the bottom, table 916 was a combined table where you had a number of different scenarios for the uplift capacity of bearer connection tie-downs. What they've had to do now to make it comply with accessibility requirements is actually split that up into individual tables. So that same section on the right-hand side is now table 916A and then a separate table 916B. And this goes throughout all those multiple table areas. That means you'll also find that the document, which was 270 pages long or so, is now about 320 pages long, just to allow for the extra room to have all those extra headings and in the changes. Not that it really affects the, there's nothing there technical that's affected, but there are some reasonable layout changes in there. From there, if we have a look at the section on flooring and decking, section 5, one of the main things that was confused a bit was what type of flooring and decking did that mean to take into account. So there's been a clarification there saying that is for structural strip flooring and not overlay flooring. And that's included both in the original, in the general section at the beginning, where it says it has to be laid as a structural element directly onto the joists. And it's not applied to timber flooring that is fixed over the top of a structural subfloor. So it doesn't rely to overlay or engineered floors. And then in each of the sections after that, as you can see in the bottom right-hand corner of the slide, we've included the word structural in there. So you've just gone from strip flooring now to structural strip flooring. The note 2 as well says that it will also comply to structurally graded flooring that's laid on timber battens over concrete slabs. Again, so this section is totally on structural and not engineered overlaid flooring. If we have a look at the expansion joints, a couple of minor changes there just to keep in line with current practices, in that if you're doing a wide expansion joint, that's been increased from 10 mil to 12 mil, and a requirement there to have a cork-filled gap and have it blocked underneath that. So there still is the alternative there to have a number of smaller gaps rather than the one expansion joint, or to have the boards loose cramped if you've got quite a large width there. There's also been a note added to that section which gives you more emphasis on acclimatisation and trying to make sure that the moisture content of the boards matches the in-service moisture content. From here we look at the nailing of boards. So there's been a single nail fixing allowed for boards up to 65 mil wide. We've had a requirement there that flooring adhesive is required for all boards over 85 mil wide face fixed. And if you have a look at the section, it says that the mechanical fixing shall be supplemented by a minimal 6 mil bead of polyurethane or polymer flooring adhesive. So that shall means that it's a mandatory requirement. In standards, the word shall means it has to happen to comply with the standard, and the word should is a strong recommendation. The other thing that's happened in here is if you are face nailing, there's a single option for nails, and engineered wood products have been included. Table 5.1 used to have different nail specifications for hardwood joists or softwood joists, whereas now it is a combined specification. So it's one nail, 50 mil long nail for hardwood, softwood, LVL or I-joist joists underneath. And finally, we've added some secret nail sizes into the specification, and flooring adhesive is required for all board sizes. The 2010 version of the standard did not have any recommendations for sizing of secret nails for the flooring. If we look at plywood and particle board flooring, there's been no changes there. The only addition has been a note. And again, notes in the standards are recommendations. So a note suggests that if you're putting an overlay flooring on top of a sheet flooring, like a plywood or a particle board, and if that overlay flooring is above 750 kilograms cubic metre, so a hardwood overlay flooring, then it's recommended that you put screws and adhesive to fix the plywood to the joists. And that is both for plywood and for particle board flooring. And finally, in section 5, with the clause on decking, clause 5.8, the maximum deck board used to be 100 mil width, but now it's been increased to 140 mil width to allow for the increase in those medium-sized decking boards that has been taken up. And screw fixing has been included for decking boards. So again, only being a recommendation, on table 5.5, note 1 down the bottom allows for 10 gauge by 50 mil long screw to be put in for boards. So they're really all the changes for the flooring and decking section. Now, if we look at pitch roof construction, there's clarifications really around the two definitions. When we have a pitched roof, there's two types. We have a coupled roof and a non-coupled roof. So the definition of a coupled roof has been has said there that there are horizontal members that combine with opposing rafters to create a triangulation of the roof structure. And then the note down the bottom says that in a coupled roof, both gravity and wind forces can be resisted by axial forces in the rafters, collar ties, and ceiling joists. So those two words, triangulation and axial forces, mean that a coupled roof has to include really those three components. It obviously includes rafters, but it has to include a collar tie and ceiling joists. And those, especially those ceiling joists, which are at the support base level, they provide resistance to the axial forces and stop spreading of the rafter pairs. If you compare that to a non-coupled roof, so it's quite simple. It says a non-coupled roof does not incorporate triangulation. So that means that rather than having ridge beams and, rather than having ridge boards, which are in a coupled roof and collar ties and ceiling joists, a non-coupled roof requires ridge beams and intermediate beams. So these are full support beams that support the roof. This is something that's often mistaken in normal construction or in some types of constructions. So a coupled roof to AS 1684 needs collar ties and it needs ceiling joists to create that triangulation. So if you look at the photo on the right hand side there, that pergola includes collar ties, but it doesn't include ceiling joists. And there is effectively no ridge beam there because there's no support at the end. It's a hip on both ends. So that is not a coupled roof in accordance with AS 1684. Now, that doesn't mean that you can't actually build that or do that. What it means is that that roof needs to be specifically engineered, and especially the connections and the design of the rafters need to be engineered to resist the loads. So if you have a vaulted roof in a house, which is becoming more common in certain areas, al fresco areas and things like that. If it doesn't have collar ties or ceiling joists, then it must have a ridge beam, or it must be specifically engineered with connections to resist the loads that are applied to it. Okay, so there you go. That's the end of part one. Just to note, the standards can be purchased online. There's 3 different websites that I know of at the moment. So SIA Global, which was the original and been historically the place to get the standards from. But there's also been 2 others added in recent years, Tech Street, and the Australian standards have their own store that go through there. So there are also hard copies available from a lot of the organisations such as the TDA, HIA or MBA. So, but if you have any issues getting standards or looking for standards or any questions about that, then Andrew or Boris are probably the ones to talk to in there. Okay, thank you for that. I will now stop sharing and let Tim take over.
Thank you very much for everyone attending today. I've been watching the chat go past. Having 1,500 people, there's a mile of questions go past, much more than normal webinars that I'm watching. As Andrew said, my name is Tim Rossiter. I've been with MiTek for a little while now, nearly 25 years, and Bossage before that. Most of you would know MiTek as being a provider of nail-plated products into the frame and truss sector. We do a fair bit more than that. Feel free to call me at some other time if you want to go through some of the other things that we can do. So let's go through the changes that I've been allocated to chat about. I want to have a brief look at a couple of construction practices, and then we'll dive into a bit of bracing and some tie down. I'll add some editorial as we go. Normally it'd be more fun to do that if you could talk back to me, but we'll do it anyway. Just some of the things that I've noted that'll go into the list of things for Boris to have a look at for changes in the future. Things that have been outstanding for a while, and it'd be good to see them picked up on the way through. So let's get into some construction practice changes. So the main one in this area of note is a change to the consideration around notching and trenching. Previously, there was a fairly generic diagram, showed lots of notches and trenches and positions of holes you can put in studs, but there was no specific dealing with non-load bearing walls. That was always to be assumed to be a structural wall. So the code's now broken that into two sections. One section for general load bearing external walls and internal non-load bearing walls. Now be a little bit careful. Non-load bearing doesn't include brace walls. So any bracing wall is still counted in the general area. So if you want to apply the new rules around non-load bearing walls, you have to exclude all those walls that are considered to be bracing walls. Now, there's a little bit of interpretation to be made at that point, because I have seen plenty of cases where people will diagonally brace a wall just to stabilize it, but it doesn't contribute to the calculated bracing for the building. In the terms of building inspecting, probably safer to just err on the side of caution. If it's got a diagonal brace on it, apply the standard rules. If it doesn't, then you can apply the new rules. And the new rules are broken into 3 sections. The first section is about the plates, noggins, and studs, and that defines the hole size, where you can put it, and how close they can be apart. Interestingly, just as commentary, we still maintain this inability to get away from imperial measurements. So 52 millimeters, 2 inches, still many decades since we stopped using imperial numbers, and 1800 being 6 foot. Thankfully not 1803, so they've at least moved away a little bit. So the maximum hole size is a 2-inch hole. There's no nomination about the stud that applies to. So that would be just as applicable in a 70 mil frame as a 90 mil frame. And you've got to put it pretty close to the middle and no closer than 1800 apart. That's in plates and noggins. If we move into studs, same thing, 2-inch hole. You're only allowed 1 per stud, and it has to be, it can only be 1 in 4. So that means that if you've got a requirement for an HVAC plumbing system or a pipe work going through non-load bearing walls, if you're going to this sort of size, you can't put it in a line stud by stud by stud by stud adjacently. Also talks about notches, maximum 50%, only 1 notch per stud, and again, only 1 in 4 adjacent. Now, it does make a comment in the code, which is up to a little bit of interpretation from those doing the inspection, and that is that it's not to be adjacent to a significant timber defect. So it's up to the judgment of the inspector or the carpenter or whoever's putting the hole in the stud as to what a significant defect is and how close adjacent happens to be. So a bit of common sense. You've got a loose knot. You go put a 52mm hole. There's not much air, not much timber left. There's more air. So keep things a reasonable distance away. And I use as just a generic term as not adjacent to. A couple of notes from things that didn't make it into the construction practices, and that's a clarification on block grading. There's been some discussion in recent times around the requirement for members within a wall frame to be graded, which one should be, which one shouldn't be. It's clearly noted that noggins are not required to have a structural grade. It's not clearly noted that blocks are not required to have a structural grade. And there's a standing request for change in the next round of 1684 that's been put up to try and just deal with that fact that the code is silent on whether blocks should be graded or not. And there's been a bit of interpretation in both directions from multiple people, but there are no specific instructions within the code. So that's a hole that just needs to be plugged. So moving on from construction practice to bracing, this is probably the section where you'll see the most significant change that actually isn't a change. So the bracing capacities for sheet braces, when you first glance at the table, you'll see the number on the right-hand side of the screen there. If you do a lot of bracing calculations, you'll know that number is 3.4. Well, it's no longer 3.4, now it's 3. The reality is it hasn't changed. What has changed is the recognition that the more common material in use these days is JD5 and the least common is JD4. When these tables were originally created, it was the reverse. And there was a note put in the code that basically said, if you're using JD5 stud material, then you shall reduce the capacity 3.4 by 12.5% for the G to K plywood brace systems and by 16% for the hardboard systems. So remembering that a sheet brace or a ply brace, the capacity of that brace is not contained within the material itself, it's within the connection to the framing around it. So if you've seen any tests done of racking forces for sheet brace, you'll find that the predominant mode of failure is a nail pull-out in the corners. So as the force is applied, you get tension and compression, and you'll find that in this corner here, that the nails will pull out of the plates, and then the nails will pull out of the studs in the same region. Then you get excessive movement, and then the brace is ostensibly failed because it's a deflection check. It's very, very rare to have a pull-out where a burst out where the nail actually bursts off the material. Most of the time, it's going to be a nail pull-out. So that number has altered. It's gone from 3.4 down to 3. But doing the calculation, if you're using JD5 materials, that's what you should have been using all along. Note, the other most common one that most people see is this one, where that used to be a 6 and a 7.5. Those numbers have also dropped because of the materials most commonly used. Now, there's a little bit of maths for those that are pedantic. The increase versus a decrease by a percentage is a bit open to interpretation. Do you divide by 1.125? Do you multiply by 0.875? How do you reduce by 12.5% or increase by 12.5%? It doesn't really matter. The number going from 3.4 down is probably 2.9 something or other, or if you go from 3 up, it's just over 3.4. It's close enough. Because when we're doing bracing calculations, it's not rocket science, it's not precise. The areas that you calculate are rough areas generally. So when you do your bracing calculation, you're doing your area of influence, you don't take off eave areas predominantly. You generally just take that area straight across. You do calculations to the nearest half a square metre at the worst, and then you apply a pressure factor from the code, which is only down to 2 decimal places. Then when we're adding brace units in, you're really only adding a brace unit in at a time. And the length of the brace unit multiplied by its capacity, the calculations that you do should never be taken down to any more than single digits, let alone decimal places. So the difference between 3 and 2.94 or whatever the actual number is irrelevant, and I wouldn't be worried about it. The calculation, though, you're going to have to be more careful with. So those that are used to using this 3.4, check with your material supplier. If your material supplier is supplying JD4 material, then you can stay with 3.4. If the material supplier is supplying JD5 material, you need to drop to 3. The general practice for most people when they're doing calculations of brace units is they generally just used 3 anyway. It wasn't a number most people used was 3.4. They'd use the 3. They leave the 0.4 up their sleeve if they were running out of bracing and go back and do a quick check. And if they need to grab another couple of kilonewtons, it was available. The one that's more likely to catch people out is the number 6 is a lot easier to use than 5.6. So, or sorry, 5.2. So those numbers will be ones that you'll need to account for in any spreadsheets or calculations that you currently use. So if you're using a secondary tool, the Timber Solutions bracing calculator, for instance, or many people have spreadsheets they've set up over the years, check with your supplier. If the material has changed to a JD5 more commonly, change your spreadsheets to accommodate. A little note tucked away at the bottom of type G is an attempt to address one of the common questions we get on site, and that is if you put ply brace on both sides, how should you tie it down? In the past, it was, well, you double the brace, so you double the tie down, but it wasn't very easy to double the tie down when it says nominal fixing. So you'll note now at the bottom of that table, there's a note that says, if you're fixing both sides, then you use diagram H, method A. So you see diagram H, which is this one, method A, M12 rods, if you're putting ply on both sides. So that makes it very clear now, if you're putting ply in accordance with diagram G, which is that one, and you're doing it to both sides, to tie that down, you're going to need to use M12 rods at either end. So that makes it crystal clear as to how to manufacture, how to do that. If you're using diagram H and you're putting it on both sides, so plywood fixed to both sides of the wall, go to those other clauses because the loads get quite high. So the capacities get quite high. So if you're multiplying these sort of numbers, 5.6 and 5.2, and then you double that again, the amount of tie down at the ends of that is quite significant. So you need to go and refer to these other clauses to get the right tie down capacity so you can transfer that load down through the building. Quick note about not yet changed. Fairly common material these days in the marketplace is JD6. You'll note that in all the tie down sections of the code, you can do tie down calculations for JD4, JD5, and JD6, but it hasn't yet crept into the bracing section. So in the list of things to be looked at, that would be a good one to include as to what the capacity reduction for bracing is using a JD6 based material. And the other one that is markedly absent is the inclusion of OSB. OSB has been around for decades now, and the manufacturers have certifications on how to do the bracing calculations. They are not joint group dependent for the base material, and they've done tests to prove that. But the reality is that OSB is probably most commonly used as a brace board in 2 of the 3 major East Coast states. I've been involved in jobs in the past where a general practice engineer has done a building inspection and he couldn't find OSB within 1684, so failed the building as being non-braced. In fact, he thought it was a decorative plywood in that particular instance, so we were able to direct him to the right documentation and get him back on the right track. But it would be good for the code to recognise common materials, JD6 being one and OSB being the other. A little bit on tie down. There's not a huge amount of change in tie down, just again, a recognition of some of the realities of things that are done that haven't been in the code in the past. One is the ability to tie an upper story to a lower story and bypass the floor system altogether. So currently within the code, it's a linked chain. You connect your upper story to your floor system to your lower story, and it's a 2-link chain. There's quite a valid way of doing that connection by bypassing the floor system altogether, and running a strap past the floor from top frame to bottom frame. So that's now included in the code as a deemed to satisfy solution. Be a little bit wary about the lengths of these straps, because to fit 12 nails at the end of each strap, that's a fairly long bit of material. The other gap that's been in the building industry for a while is that gap between masonry construction and timber frame construction. 1684 has been very clear on load path if you build everything out of timber. And the AS 4773 masonry code has told us how to connect wall frames, or sorry, framing material to brickwork, but it hasn't crept into the same standard. So that's been recognised and they've been brought in together now. So these details are common to both standards. And we've got two new details put into 1684. One is attaching a timber plate to the brickwork, and then you can take your load path from the timber plate back up into your roof system. And the second is to bypass the wall plate altogether and go either off a beam, so rafters or trusses all the way straight down into the brickwork, and then strapping the beam down. So you can have a top plate down here that's irrelevant. So you've strapped the rafter directly to your brickwork, and your top plate, which is like a washer in that instance, isn't doing any connection loads at all. And you can do it in this method as well, where you attach the batten over the top of the heel of the truss, down into the brickwork, and there are details as to how you're supposed to do that strap into the brickwork with cross members to attach in the brick system, how many courses are supposed to go down. All those details are in 4773.1. Be wary of corrosion and exposure to the coast, because as soon as you would start attaching metalwork to masonry in a salty environment, you can encourage corrosion, and there are rules about what that base material needs to be, depending on your proximity to salt spray or ocean. So you're going to need both codes basically, but at least the documentation is the same between two. Watch out for the batten design. Okay, so the batten design here is a 9045 P10 or 9035 P12. That is not a common batten material. So if you're going to use a tie-down batten, you need a stronger batten at that point to take that load. The other note that I would make is that there's an allowance for up to 5 nails neatly around the perimeter of a 90 by 35 or a 90 by 45 material. Getting 5 nails evenly around that is, in my mind, probably a bit of a struggle to get it evenly without busting the batten to pieces and splitting it apart. So I would probably be recommending you stick up in the 3 or 4 kilonewton capacity. Note, as I said before, here are your capacities for JD4, JD5, and JD6, depending on what material you're using for your batten. And then you have your connection. That's this connection. The capacity of this connection, you need to go to 4773. So all this is telling you is in your terms of your load path, and you're taking your load path down in the building, this will get you this many kilonewtons to here. You've got to make sure that the masonry connection complies with whatever number you're using here. So if you've managed to use 4 nails in some JD4 and you need 6.5 kilonewtons worth of tie down, that's great at this point. But make sure you go to 4773 and say, well, how do I achieve that down here? How many courses of brick do I have to go down? What cross connection do I require to achieve that number? And you'll note in the note here that the capacity may be limited by the connection itself. So whatever is the lower is the governing factor. There's a second note there about battens of alternate size of materials, but then you have to design those specifically to 1720. It's not deemed to satisfy as these ones are. The last tie-down detail I wanted to cover was just, again, a recognition that there's some materials in the marketplace that are not imperial. Your 38 and your 50 mil batten. There's a 45 mil batten, have been used for quite a long time. So it's now been added and recognised in the code that that's an existing batten type, and capacities have been given. Note that if you're going to use 2 screws, it's got to be 75 mils wide minimum. So basically that means it's going to be a 90, because there's not many 75 base material standardly in 75 by 45. So you're going to be 90 by 45 to use 2 screws, 70 by 45 you can use a single screw, and here again is your capacities. That's all that I've got in my section to go. So I'll allow the questions to flow in the chat and hand over to Boris.
So look, thanks everyone, and it's great to see that there's so many people registered for today's webinar. Thanks to both Tim and George for taking us through the changes to 1684. I think the thought was that it would take the opportunity, having so many people online as well, is to seek some suggestions or some comments from the participants as to potential changes to 1684 to take account of new construction practices or whatever. So I suppose I get the exciting part to talk about where the standard is potentially going, but also seeking that input from the participants as to where it should be going. One thing I wanted to just point out, I saw there's a whole lot of chatting going on. As part of the webinar, we do get copies of the Q&A, or the questions and answers. So as part of my presentation and people wanting to suggest or make comments, would you just use the Q&A button? I can't quite remember if Andrew mentioned that at the beginning, but I just thought I'd reinforce that. So if you have any suggestions or any specific comments, please just put them under the Q&A section, and just put the word suggestion and then just your comment after that would be fantastic. So look, AS 1684 has been around for quite some time. So the original version of the Australian standard came out in 1946. So over the years, as the loading codes have changed, practices, we've then, AS 1684 has evolved. So, but over the decades of use, there's been a whole range of timber products used and demonstrated their design flexibility, their proven reliability and adaptability. And as we're going forward, the need for sustainable building materials has never been as strong from a climate change perspective. But where can the standard go, and what sort of things should be done to try and improve its use or provide new building systems and elements? One of the key areas that's being developed is lightweight panelised systems. So look, yes, you can use, say, wall framing. If you're looking at roof systems, you can use a panelised system in there as well, but it needs sort of some thought as to the use of the element and connecting that to the timber frame system. But today we're having more prefabricated systems that are being used to construct our buildings, and there might be, or not might be, there is a need to actually start to consider the use of these other elements with our traditional frame systems, but also in our wall systems. So our traditional open frames, so as we're either prefabbed or on-site stick built. But we're now moving into partially enclosed systems where we're cladding some elements and we're installing window elements, or we're going into fully clad systems. Just need to start to think about the modification of 1684 and how we start to incorporate these systems. But also there's a whole lot of floor cassette systems that are being used even today on the first floor of a two-storey house, where we can just drop in floor cassette systems to enable the speed of construction as well. So I'm not saying you can't do that today, but more that 1684 should be starting to think about the adoption of these new systems and incorporating them into the standard itself. But there are other ways that we can frame systems. So we can start to introduce portal frame systems into 1684 to take out lateral loads in our buildings to enable us to do wider openings. And there are some building systems that are being promoted today in the market, both the truss frame systems as well as the typical framed material systems as well. So there's no reason why these systems can't be genericized and put into AN 1684 as brace or portal systems. It's been mentioned as previously, I think Tim mentioned about the use of orientated strand board. So that is being used in the market. I did see a chat comment about saying be careful about the use, making sure that it's being manufactured in accordance with an Australian standard. At the moment, we don't have an Australian standard manufacturing an Australian manufacturing standard, but these products are manufactured to a standard by the supplier or the manufacturer, and so they certify that the standard's been manufactured in accordance with an American standard or an international standard. I suppose one of the key things as well is the fixings that are used to install these sorts of panelised bracing systems, typically just using staples, and 1684 at the moment doesn't look at the use of staples, so it typically has nailed systems. So we need to look at, these systems are being used, they have been tested, and they're proving to be very efficient and a very useful system to have. So the 1684 does need to look at these other building products and materials. Yeah, some of the other benefits, looking at fully sheathed systems. Now, obviously you can do that with 1684. I tend to watch a lot of construction and building shows from overseas. So the top right-hand image, typically of an American house, and you'll see that there's basically no noggings in that wall frame. So when they sheathe the house, as we can do in Australia, they'll tend to not put noggings on those external walls. They'll have internal noggings on internal walls where they don't have the ability to sheathe it. So there's those sorts of concepts. We should be looking to how we can adopt them here in Australia and make more use of them. These sorts of panelised systems are very beneficial to our frame and truss sector, where obviously the simpler we can make the building systems, the more efficient they can make the manufacturing process. But there's also a whole range of new connectors that are being used that we don't have in 1684. Typically a lot of screw type connectors. The image at the top right, showing screw fixings through plates into wall studs, and the image beneath it is screw fixing from below the top plate, from underneath, and screwing up into a rafter or a truss. So there are these systems are in place today being used overseas, that we should be looking at how we can adopt them and use them here in Australia as well. But what about the use of, or a higher or a greater number of stories in our buildings? So, there's a lot of 3-storey townhouses being built that can be done in a 1684 approach. Andrew will recall that we do have 3-storey or stud frame designs, wall frame designs for 3-storey buildings that were released probably 15 to 20 years ago as span tables. So we knew how to do it back then, but it just hadn't flowed into a 1684. So industry had as generic documents. But going through the formal public comment process, we put these documents out and have feedback, I think would be very beneficial for the development of 1684. So, this is one of the areas that I think there might be an opportunity for further development of 1684. But again, any ideas or any suggestions would be greatly appreciated, either via the Q&A section, or if you have any other thoughts after the webinar, through the info@woodsolutions.com.au, and those comments will be forwarded to myself or Andrew as part of the development of 1684. As part of trying to also assist in the use of 1684, industry has developed user guides to try and show how 1684 can be used. So, the discussion about, there's a design guide number 1, just generally about what nominal fixings are, specific fixings, and when you need to either use straight a specific fixing design, such as tying roofing battens down to your roof frame, as opposed to a nominal fixing where it may just be fixing of bottom plates in a low wing classification to a slab or to a timber subfloor. So there are some information sheets or information guidance that can help people in the use of 1684. Again, if you go to the website and just search for AS 1684, this page will pop up. So look, I'd just like to thank you for your attention. I'll hand back to Andrew, but again, we really like to take this opportunity to seek any further comments or direction or suggestions for direction for 1684. So thanks very much.
Okay, thank you, Boris, and actually thank you to Tim and George as well. Very very thorough presentations. We have time for a few questions, and I'm going to see if we can share them around between our speakers. So I'll start with one from Michael, and this is aimed at you, George. He's talking about in older buildings, the ceiling joists often swap directions between rooms and may not be continuous in the same direction as the colletized. Can it still be considered as a coupled roof?
Yeah, that's a very good one, and it's very hard for the standard to basically account for every single scenario. As soon as you try and put every scenario in, the first building that gets assessed is going to have something totally different in there. What we have said in the standard and underneath that coupled roof construction, there is a note there that says in certain areas it may not be possible to have collar ties and ceiling joists on every single rafter pair, and that brings in those areas like Scotch valleys and hip ends and those areas. So, but it still says that it is part of a coupled roof construction. So I suppose it's a matter of people to look at if you do have large areas which don't have a full triangulation, or how you actually get to that triangulation, but that'd be on a case-by-case basis.
Okay, George, thank you. Question for you, Boris. This is from Steve. Is it envisaged, and can you include the reason why 1684 Part 4 will continue to be published in the future?
Yeah, look, I did hear George say that 1684's Part 4 is not used that often, but I'm based in Victoria, and I'll say that it is sold quite a lot in Victoria. It is a very simplified document, so it takes a bit of that design work out, still having obviously it's based on Part 2. I think you'd find that there'd be some reluctance for getting rid of Part 4. I know that it is a simple document, and I know Wood Products Victoria also do provide sales of the publication, and I think it's their biggest seller from the AS 1684 suite is the Part 4 here in Victoria. So I don't think it will be lost.
Okay, and just to add something to it, there was a question which I can't remember who said it, but there was a recommendation for a span table, because in actual fact, the edition 2 and 3 actually have size tables. Part 4 is actually a span table, so it has a different format if you're looking for that. So there is a value for it. A question, and I'll aim this one at Tim, and it's from Heather. When will the 21 edition be adopted in the BCA? It's actually one of our CPD questions.
As far as I'm aware, when NCC 2022 calls up this version of 1684 by date. So when that's adopted, this will become legal.
And Boris, would you add any comment to that?
Oh, look, that's right. There has been, and Tim mentioned the blocking matter about non-structural blocks or the grading of blocks, and there is actually, even though 1684 has been released, there's going to be some fine tweaking happening. There will be an amendment released which will just pick up on some minor changes. So the blocking is one of the key ones. We'll also be referencing some of the product standards within 1684, and that has been basically agreed to by the national regulators through the Australian Building Codes Board. So there'll be a minor adjustment to pick up some of these small technical matters. And so you'll find actually in the NCC 2022, what should happen is AS 1684 suite of standards, including Amendment 1, will be the call up. Now, those that have got current copies of 1684, the 2021 edition, you can get, once the Amendment 1 is released, it'll be as a free download. Like I say, it won't be big. It might be one page, one A4 size page at most. So, very simple change, hand changes could be made to the standard itself. But look, that's, I suppose, what will be coming in the future.
Okay, thank you, Boris. And at this point in time, I think we're running out of time for this presentation. So I'd like to thank the speakers, George Dolezal, Tim Rossiter and Boris Iskra. Brilliant presentation, and you attracted a very large audience. So we thought there was interest in standards, which we think are relatively too dry. So just completing today's webinar, as you said, the standards are available, and there's we're pointing to It's available from websites, obviously from the producers of standards. It also is available from the timber associations as TDA. So we sell hard copy versions and they're available. Now, one site that just for young players is the Tech Street, which was advertised by George. That's in American dollars, so don't think they're cheaper because that particular website's in American dollars, so it's an American website. So just a reminder of the CPD questions, to name one change, and you can see there was many of those changes for and describe the changes that have been made to the supplementals or span tables. Well, there has been none, and when is it likely to become law? And we said NCC 2022. You may note that the draft of the NCC 2022 refers to 2010 version, but that's been corrected as discussion from Boris. So just a reminder that this webinar will be available, and one of the questions for this was going to be available later. It will be. Just gives us a little bit of time for it to get it down the cloud and into the Bush Solutions website. And a reminder that after this webinar, there'll be the certificate sent out for your attendance, which will include the 3 CPD questions. And please keep that, and it's for your benefit. There will be some questions in it, and we do encourage you to let us know what you want to hear, because we're quite surprised that there's so much interest in the standards. So we might be able to include more in future webinars. So on to what's next webinar. Next webinar is in 2 weeks' time on the 14th of September, and in a little bit of a change and it's in September, spring has arrived, so it's obviously the time to talk about decking. So we have two great speakers who are going to talk about specifying and maintaining residential timber decking, and there'll be Dane Kearns and Justin Scooby from Bull Timber. So welcome to attend that one. So that's it for the webinar for today. We're right on 12 o'clock. We'll thank you for your attendance and see you at the next webinar. Thank you all.